Hey, welcome to 5-6. This is a lesson on probability distributions. It's a little bit long. There's a lot of reading here. There's a lot of detail. It presumes you know something about probabilities and frequency. So a few things just to hit the vocabulary. You need to know the vocabulary that's listed up here on the right. You also should know what frequency is. You should need to know what relative frequency is. You should understand what those mean relative to probability. And I'll give you a little bit real quick. Relative frequency is what actually happens. Frequency is what actually happens. Relative frequency is the comparison of what actually happened in some category to what happened in total. There's a little discussion about that at the lower part of 280. Probability is something that's determined either by using a relative frequency, by deducing it, or guessing, just making a best guess. So probability is a mathematical construct that could come about from knowing something. Frequency is an experiment, or an event. Something actually happened and you had a frequency. Relative frequency comes from that. Okay, so we've got this discussion on how probabilities are determined. We have probability distributions. You have this chart of die outcomes. This is for two fair die. There are 36 possible outcomes. In some cases, even though, as in, let's see, right down in here, I've got my 1 and 2 and 2 and 1. Those are two different outcomes because each die had a different result. So you can see the position is different, indicating that the die order was different. The sum is the same. So there's a difference between how many possible outcomes there are and what is the sum of the result. And that's discussed down here at the bottom of 281. We've got our chart from that discussion of sums, and you can see that indeed there are not a total of 36 possible events, but within some of these events, 36 possible sums, there are 11 possible sums, but within it there are multiple ways the sum could occur. So it gives us this answer, this discussion about probability of an event with equally likely outcomes. Take a look up here at QY1. This is quiz yourself 1. The idea there is that you try this and see what you get. In tossing two fair dice, what is the probability of tossing a sum greater than 8? Well, how would you set about doing that? Why don't you go ahead and kind of think about this, try it, and then come back in just a second. Okay, I hope you paused it and you're back. And we know that if it's greater than 8, then that means it's 9, 10, 11, or 12. So that's the probability that we're going to get, is if it's 9, 10, 11, or 12, how many different ways can we get a 9, a 10, 11, and a 12? And then how many possible ways are there to get any outcome with the die? And that's 36. And so what we would do is, for the number of outcomes in the event divided by the total equally likely outcomes, which in the case of the die, it's equally likely it could be any one of 36, nothing's preferred. The total number of outcomes in the event is the sum of the ways that we could get 9, 10, 11, and 12. We divide the number of outcomes by the number of events. Relative frequencies is discussed next. And we've got an example. I'll be going through a similar one. You should read through this. And then we have what's called a conditional probability. Conditional probability is, from solution B, is dependent. It's if a person is type O, what is the probability that they are O negative? And we've got a solution here where it tells us what that was. But the general equation for this is the probability of B given A. So that's the probability that B happens given A. In this case, probability that you're O negative given that you're O. And so that probability, it's the probability of A and B. A and B is an intersection. It's the probability that both of these happen. So it's the divided by the probability of A, which is the probability that you're O positive. Is that okay? So the probability you're O positive is 46.1%. The probability that you're O negative, so in other words that you're O and negative, is 7.7%. We can do that and we get a 0.167, which is about 16.7%. Next up is complementary events. The complement of an event is the opposite of it. If you flip a coin and you flip heads, the complement is that you flip tails. It should, an event and its complement, the event and the not event, they should add up to 1 in terms of the total probability. We have a discussion about odds. You should read this carefully. Then you go back and read it again, also carefully. The odds of some event occurring, E, is the probability of the event divided by the probability of the complement of the event. The other way to look at this is that in the discussion below, if you think your odds of being selected for a particular honor are 2 to 1, then that means you will be selected 2 out of 3 times, and that the probability of the event is 2/3. This shows how to calculate the probability from the odds. If the odds for an event are m to n, then the probability for the event is m over m plus n, and the probability the event will not occur is n over m plus n. That would be the complement. And I'll go through an example about odds and talk about it a little bit. The key here is to understand that if the odds are 2 to 1, then that means you'll be selected 2 out of 3 times, and the probability is 2/3. Okay, sometimes people think if it's 2 to 1, then it's either 1/2 or 2. Doesn't really make sense. All right, so I'm going to hit some examples. Be back with you in just a moment. Okay, here we are with excuse me. Yeah, here we are. 5-6, some extra examples. And the first one up is a card one. I'm going to go through a little bit more about cards with you in a second. A card is selected at random from a standard deck. That means it's a fair deck, no jokers, so it's just the 4 suits, 13 cards in a suit. And question A is, what is the probability of a king or a queen? Now, king or a queen means it could be a king, it could be a queen, and either one of those would be an acceptable outcome. So what is that probability? So we've got a standard deck, a standard fair deck. And what is the probability that it's a king or a queen? Well, in each of the suits, we have hearts, spades, diamonds, and clubs. Wow. Each one of those has 1 king and 1 queen. So out of this, that means of the 4, there's going to be then 8 there's going to be 4 kings possible, 1 for each suit. There's going to be 4 queens possible, 1 for each suit. That's 8 possibilities. And it's 8 out of how many cards are there altogether? Well, it's a standard fair deck, so there are 52 cards. The probability that I draw a king or a queen is 8 out of 52. Now that can be simplified. I know that 4 will go into 8 2 times. I know 4 goes into 52 13 times. So my probability is 2 out of 13, or 2/13. You'll notice I didn't express this as a percentage. A mistake that's commonly made is to assume that probability is a percent. It is not. Probability is a number from 0 to 1. Let me repeat that. Probability is a number from 0 to 1, where 0 means it never happens, and 1 means it always happens. That's what probability is. We're used to hearing probability as percents because that's what the weather forecasters tell us. The probability of rain tomorrow is 5%. Whatever that number might be, we get used to hearing that, but that is not what probability is. So you should repeat this with me. Probability is a number from 0 to 1, where 0 means it never happens, and 1 means it always happens. Where this is useful to you is that if you get a probability of 5, you know something is seriously wrong. Because if 1 means it always happens, what does 5 mean? It really doesn't make any sense to even think of it that way. So keep in mind what it really means, and it'll help you to make sure you get answers that are correct. Okay, step off the soapbox. Let me get on to part B. What are the odds the card is not the ace of spades? Well, now we're talking about not, so we're talking about a complement. So if it is the ace of spades, how many ace of spades are there in a fair deck? There's 1. That's 1 out of 52 cards. Well, a complement means that the complement of the ace of spades is all the other cards. So 1 out of 52 plus its complement is going to equal 1. Everything. So I have the event that I'm interested in plus everything that's not that event, and in total that's 1. If you took all of the cards, eventually it would all happen. So to find out what C is, it's simply that C is equal to 1, the probability that everything happens, that we could draw any card, minus 1 out of 52, the probability that I draw the ace of spades, and 1 minus 1 out of 52, I change this to a fraction, to 52 out of 52. Right, you got that, yeah? Right, so 52 out of 52 is 1, minus 1 out of 52, that is 52 minus 1 all over 52, which equals 51 out of 52. So the answer to our question is 51 out of 52 are the odds that the card is not the ace of spades. Okay, I've got something a little bit fun to do regarding relative frequency. The first card I drew was this 5 of clubs. The question here is, what is the probability that I draw a black card from the deck? I'm going to put the 5 back in here. When I do the again, it's going to replace it. So it will still be 52 cards. And what's the probability that it's going to be a black card? And some of you might be looking at this and saying, well, there's already a black card, so that it's not as likely for there to be a black card on the next draw. And that's not the case, because once I put it back, there are now, if it's a fair deck, there's a set of red cards and there's a set of black cards, and it's going to be 50-50. So let's try it. We're going to hit again. Guess right now, red or black? What's it going to be? Okay, it's black. We got a 2 of clubs. All right. So I'm going to do this again, put it back. I want you to guess again. Tell me which way it's going to be, red or black. Hey, 7 of spades. Okay, so it's not a club. And we'll do it again, red or black. 10 of clubs. We got another club. Okay, so 10 of clubs. And red or black? What do you think? What's going to be next? Red or black? Hey, black again. Are you beginning to get suspicious that something might not be right here? You should be. And here's the point of this exercise: is this is not a fair deck. This is in fact 2 decks, but with only the black cards in it. What's interesting is when we talk about guessing at probabilities, at some point in this you got suspicious that it was not a fair deck. Likely, I would suspect for a lot of people it's about 3 cards where they begin to think something's wrong. Just about everybody is there by the 4th card, and certainly the 5th and 6th card you begin to go, wait a second, this is not right. So that's just an interesting exercise in terms of our sense about what is a fair probability. Is it possible in a fair deck that I pulled 4 black cards in a row? And the answer to that is yes, it's possible. It's not highly likely, but it is possible. Let me get rid of that. Okay, so I'm going to go do this again, and we're going to have a fair deck with replacement. And I just want to ask the question about what's the probability of having pulled that 1 card. So we'll go to draw cards. And I've got a 7 of spades. Well, what's the probability that I drew a 7 of spades from the fair deck? Well, there's a total of 52 cards in the deck. So if there's a total of 52, then the relative frequency for this draw is 1 out of 52. I got 1 draw from 52. If I do it again, now I've got the Jack of Hearts, finally got a red card. And again, that's also 1 out of 52. That's the probability. Now if I go back and I do this as 2 cards, this changes things. Because if I look at it this way, the first card drawn was the 6 of Hearts. Well, that was a 1 out of 52 card. The second card drawn is the 8 of Diamonds. The 8 of Diamonds is 1 out of 51 because I've already drawn 1 card. So there was a 1 out of 51 chance that I drew the 8 of Diamonds to complete this card because of this idea of replacement. So as we take a card, we've reduced the population available for the drawing. Okay, I want to go back to this again, and I'm going to ask a different question here, which has to do with spades, hearts, diamonds, and clubs, and your knowledge about what these include. If you look at that, which card should be included, I have aces, 2s, 3s, 4s, 5s, then 6, 7, 8, 9, 10, and we have jacks, queens, and kings. Well, how many are there altogether there? Well, that's 5, 10, 13. There are 13 cards altogether. There are 4 suits. Spades is a suit, hearts is a suit, diamonds is a suit, and clubs is a suit. 4 times 13 is 52, so there are 52 cards altogether. What's the probability that I would draw a spade when I draw a card? Well, drawing a spade, there are 13 spades, and in total there are 52 cards. We already know that 4 times 13 is 52, so 13 goes into 13 one time. 13 goes into 52 4 times. So the probability of drawing a spade is 1 out of 4. So is 1/4 or 25% or 0.25. So let's take a look. I drew a spade. I got my first draw. Let's try another one. Nope. So that's 2 out. I got it one time, so I got 1 out of 1. And now I'm 1 out of 2. Now I'm 1 out of 3. Ooh, now I'm 2 out of 4. I'm now 2 out of 5. 2 out of 6. 2 out of 7. 2 out of 8. 3 out of 9. So at 2 out of 8, if we go back one, then I was at, back to 1/4, so at 25%. Now that I've drawn the next one, I've got 3 out of 9, or around 33.3%, or 1/3. This is what is known as relative frequency. This is what actually happened. The odds, the probability, tell me it's 0.25 or 25%. That's the probability. Relative frequency is what actually happened when you did the experiment, and it's not always the same as the probability. And in fact, for small numbers, we don't really expect it to be exactly the same. The more you do, the closer it gets to what would be considered the real or actual probability. So if I do more and more and more of these, it's going to get closer and closer and closer to being 0.25 or 25%. We're continuing our 5-6 examples. We're coming back to what I called example 1. It's my example 2, sorry. We can fix that. Here, we'll fix it right now, right? Right now. There we go. That's example 2. Given the chart of blood types in example 1, this is example 1 in the book, what is the probability that a person has type A positive or O positive blood? Well, the probability that it's A positive is 32.3. That's a percent, right? 32.3%. The probability that it's O positive is 38.4%. And I'm going to take these results, and since I've got percentages, this is the probability of A is, if I rewrite this as a decimal, it's 0.323, or 32 out of 100, or a little over 32 out of 100. And this is 38 out of 100, or a little over that, so 0.384. So 0.384 out of 100. And so I've got my comparison here because I've got it in a percentage form, and I can just simply add my percents here, even though, I tell you I hate that. Let's just see how it works. That would be 7. So that says it would be 70.7%. I'm going to add up these decimals. That would be 7. That would be 0.707. So given the probability, I've been given this percent what percent each one is, I add them together, and this is the probability that they're A positive or O positive in this population. Okay, part B is we're looking for what is the probability that a person does not have type AB negative blood. So AB negative, so we want the not AB negative, and that is from the table 0.7% or 0.0071 thousandths. So the probability, this is the probability of any blood type minus the probability of AB negative. That's what we're looking for, is the complement here to find out which one it is, so that it's not AB negative. This is our complement, and we'll subtract that from that. That's equal to the probability of any type is 100%. The probability of AB negative, we determined that was 0.7%. That equals 100% minus 0.7% is 99.3%. This is the probability that you do not have AB negative blood. Now we've got one more question, which is, what in this example, what is the probability that a person who has type AB blood is AB negative? So this is an AB, the probability of AB negative given AB. So part C, this is the probability of AB and AB negative divided by the probability that they're AB. So this is where we go to get this. The AB and AB negative is an intersection. It's where those both are true, which is simply the probability of AB negative. And then that it's AB is this probability here. So the probability of AB negative, we already determined that, is that 0.7%. The probability of being AB, any AB, is determined from the sum of those two, and AB positive is 3.2, AB negative is 0.7, so that's 3.2 plus 0.7 is 3.9%. We do our division. And what we get from this is 0.179. I left off the 487. We're going to just round down. And so that's would be 17.9% is the probability that you're AB negative if you are indeed AB. All right, we'll get to the next example here. And the next one. This is the pretty classic, something's in a hat, you draw something out kind of a problem. Sophia places papers numbered 1 through 24 into a hat. 1 through 20 into a hat, and wishes to pull out 4 numbers. The first 3 numbers are 1, 19, and 12. What are the odds that the 4th number is a 2-digit number? Well, this is the drawing without replacement. Kind of back to that card problem when I drew 2 cards. The second draw was without replacement, therefore the odds for that one changed a little bit. So we'll take a look at this. So the first 3 numbers are 1, 19, and 12. That's 3, so 20 minus 3 is equal to 17. There are 17 numbered cards left. That's going to be my denominator. I want that. Now I need to know how many 2-digit numbers are left. Well, out of the ones that I had that were 2-digit numbers, there was 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. And I drew 19, I drew 12, and how many are left at this point? And that's going to be 9, because from 10 to 20 is 11 steps. We took 2 from 11 is 9. And our answer for this one is there are 9 out of 17 is our odds that we will draw the 4th number will be a 2-digit number. Okay, so that's it for the examples. Wish you the best of luck on this assignment. If you have questions, please ask. I have dice, I have cards. If you would like to use them to explore some of this information, please do. Work on the vocabulary. It's very exacting. It means exactly what it says, and you need to know that. So best of luck covering the ideas, applying the math. See you on the Mastery Quiz.